Welcome to our channel Sankalp Study Success. Today in this video we are going to learn about a small topic which is pumping lemma. So let us know what is pumping lemma and how it is related to our regular expressions or our regular language. So coming to pumping lemma, here pumping lemma it is nothing but we use pumping lemma to show a language is not regular. A language is not regular. So, we use pumping lemma in order to show a given language is not regular. So, how do we prove a given language is not regular? By using this pumping lemma, so how do we define it is, let us consider z is equals to u, v and w. So it is a string or some z is equals to u, v, w where your mod z, that is length of z, should be greater than or equals to n. So now what are u, v and w? So what are the lengths of u, v and w? So now let us see. The first one is mod u, v. So combination of this mod u, v is less than or equals to n. And the second one is mod v is greater than or equals to 1. That means here length of v should be always 1 or greater than 1 but not 0. And the remaining third one is u, v power I and w. U, v power I, w, it belongs to L for I greater than or equals to 0. So this pumping lemma, it is used to show a language is not regular. And now let us consider z is equals to u, v and w where mod z, that means length of the string, should be greater than or equals to n. And here mod u, v is less than or equal to n. And also length of v is greater than or equals to 1, and for any I, that means if you can take any value of I where I greater than or equals to 0, then if u, v power I and w, it belongs to L, you will consider that, you will assume that it is belongs to L. So whenever you solve a problem, when it is not belongs to L, then you will say that the given language is not regular. If that belongs to L, then it becomes a regular language. If you are assuming that it is belongs to L, then you will contradict your own statement that it is not belonging to L. So hence we will show it as the given language is not regular. So now let us take one example where, here let us consider a language L is equals to a power n and b power n such that n is greater than or equals to 1. So that means what will be the strings which are generated from this language? When n is equals to 1, then you will get ab. If n is equals to 2, then you will get a square, b square. If n equals to 3, then we'll get a cube, b cube, and so on up to any n value. So here equal number of a's are followed by equal number of b's. So that is our own language. So if equal number of a's are following equal number of b's, then what will become z? Z is equals to u, v, w as we know. So what shall we consider? U, v and w. So let us take any one of the string as z here. Z is equals to a square, b square if you suppose. That means a, b, b, right? So you can take u value, v value and w value. See here, as v is greater than or equals to 1, that means what? V should not be null. V should not be null. That means you should take something for v. That means you should not remove what is v. That means you should not take null. So let us consider u is equals to a, v is equals to a and w is equals to bb. From this a, bb, this is u, this is v and this is w. So here u, v and w. if you can also take AA as U, B as V and single B as W. So you can decompose it into U, V and W as however you want, but the only condition is V should not be null. So here for any, now you are going to solve U, V power I and W where you can take any value for I. Now let us consider I value as 2. So it becomes UV square W. That means U is A, V square it is nothing but A square and W is BB. That means it becomes triple A and double B. So we thought that the UV square W belongs to L, but we are contradicting our statement. This does not belongs to L. So now you can say that the given language is not regular. That means you can also say the given language is irregular. So in this way we are going to solve the problems. It is quite easy, just you need to decompose any string. Either it may be AB or A square B square or A cube B cube. You can consider any string and we are going to decompose it into U, V and W and consider I value as from greater than or I is greater than or equal to 0. So you can consider I value from 0 to anything you can consider and you can solve the problem, and you need to show that the language is irregular. So here you can also solve pumping lemma using two methods. The first one is the simplest method and the second one is the generalized method. Till now we have solved a problem in order to show that the given language is not regular. The procedure which we have done in order to solve this problem is the simplest method. Just you can take any string which is of our interest, you can decompose it into U, V and W and consider any I value, and you need to show that the given language is not regular. But in the generalized method, it is somewhat different, where we'll solve it right now. Coming to the first question, we need to show that the set L is equals to 0 power I square, where I is greater than or equals to 1. It is not regular. So that means we are going to show that the given language is not regular. So what might be the strings which generates from L? This is I square. If you substitute 1, then a 1 square is nothing but 1, so we'll get only 1 0. If we substitute 2, we get 4 zeros, that means 0 power 4. Then if we substitute 3, then we get 0 power 9. If we substitute 4, we get 16, 0 power 16, 0 power 25 and so on. Like this we are going to get the squares. That means perfect squares of the numbers. That many zeros we are going to get it. So now let us assume. Now first let us solve it using simplest method. Which is the first method, simplest method. Now let us assume any string. Now first let us assume L is a regular language. Okay. First we are going to assume that L is a regular language, then we will show that it is not regular. Now consider any string as a Z string. Now let us consider 0 power 4. That means which is equals to 4 zeros. So now you need to decompose this Z into U, V and W, where now let me consider U as these 2 zeros, V is equals to remaining 1 0 and W is another 0. So now we are going to find out U, V power I and W. Correct? Now let me consider I is equals to 2. You can also consider I equals to 3, 4, 5 and so on. Now if I is equals to 2, then it becomes U, V square W, where U is 2 zeros, V square is nothing but 0 square and W is another 0. So that means what we are getting? 5 zeros, that is 0 power 5. Here 0 power 5 does not belongs to this L, right? There is no 0 power 5 in it. So it does not belongs to L. So therefore given language, that is given L is not regular. In this way, we are going to show that the given language is not regular language. So this is we have solved using the simplest method. Now let us solve using generalized method. Generalized method is a bit difficult, but simplest method is easy. Now coming to generalized method. Here in generalized method, so we are going to take what is L, actually 0 power I square, where I is greater than or equals to 1. This is the given language for us. Now you have to consider if I is equals to n, then what happens? If I is equals to n, let me consider if I equals to n, then you can say that the length of z, that means any string which is generated from that language, will be n square, right? Because I square is nothing but n square. So the length of number of zeros which we get in the given language is n square. So z, which is again equals to mod u, v and w. So length of this mod u, v and w is n square. Now we are going to take u, v power I, w, correct? So let me consider for let I is equals to 2. I'm going with a small value, I equals to 2. So if you want I equals to 3, 4 and 5, then you can proceed with I equals to 3, 4 and 5 as well. So if I is equals to 2, then it becomes u, v square and w, right? Mod of this will be something greater than n square, right? Something should be added to n square, because mod u, v, w length is nothing but n square. If you are adding one more v to u, v, w, then you are going to get u, v square, w. So we are adding something to n square. So here that means this value is surely less than n square. N square, right? And because n square is less than u, v square, w, because we are adding one more variable, that is v to u, v square and w. So let us consider which is this is less than some n square plus n plus 1, n plus n plus 1, because we are going to add something to n square in order to get v square, correct? So first let us add only n, because it is less than or equals to n square plus n, right? Because we are adding something here. So now n square is less than u, v square, w, mod u, v square, w, which if you add something more to that, then it will not be equal and it will be less than n square plus n. We are adding n plus 1, so it will be less than, right? So that means what are we going to prove here? N square is less than u, v square, w, which is less than this n square plus 2n plus 1 is nothing but n plus 1 whole square. So that means what? N square is a square of an integer. N plus 1 whole square is the successor of square of this successor integer. That means what? This u, v square, w, it is lying between two squares, two consecutive squares. So that means what? Two consecutive square between, if it is lying between two consecutive squares, then that will not lie in our given language, right? Because only given language consists of only the squares, so only the perfect squares. So this will not lie in our given language. Then you can say that u, v square, w does not belongs to L. So if it is not belongs to L, then you can say that therefore given L, which is nothing but language, is not regular. So in this way we are going to solve the problems using simplest method as well as the generalized method. So here For the simplest method is quite easy, just we are going to decompose and we are saying that it is not belongs to L. But coming to the generalized method, first we need to assume, or first we need to analyze the question in order to know about what we are going to solve. Here we are solving for the squares of the numbers. That means if the perfect squares lie between n square and n plus 1 whole square, then u, v square and w will not belongs to the given language. That means the given language is not a regular language. So coming to the next question, here L is equals to 0 power I, 1 power I, where I is greater than or equals to 1. We need to prove that this given language is not a regular language. So now let us consider L is equals to 0 power I and 1 power I, where I is greater than or equals to 1. So let us take the values which are generated from the given language. That means if I is equals to 1, if we substitute I equals to 1, then we'll get 0 and 1. If I equals to 2, you will get I square, 0 square and 1 square. Then if we substitute 3, 0 cube and 1 cube. So this goes on. That means equal number of zeros are followed by equal number of ones. That means we can write it as 0 1, 0 0 1 1, 0 0 0 1 and so on. So equal number of zeros are followed by equal number of ones. Now let us consider any one of the string from the given language. That is, now let us consider 00 and 11 as Z. Now we are going to decompose Z as U, V and W. So let us consider U is equals to first 0, V as second 0 and W as 11. So now we need to find U, V power I and W. Let us consider for I is equals to 2, that is U, V square W, which is equals to U is nothing but 0, V square, that means 0 square, and W is 11. That means it is nothing but 00011, where this 00011 will not belongs to the given language L, because equal number of zeros should be followed by equal number of ones. Here 000 and 11. So number of zeros are not equals to number of ones. So hence we can say that given language is not regular. So this is the simplest method, that is the first method, in order to show that the given language is not regular. So now let us solve the same problem using the second method, which is generalized method. In this generalized method, first we'll write the given data, where L is equals to 0 power I and 1 power I, where I is greater than or equals to 1. So this is our given data. Now let us consider UV is equals to 0 power k. That means we can consider any string, or you can decompose the given string into 0 power k, where UV, which is 0 power k, then what will be V? It will be equals to 0 power j. It is our assumption. That means let UV is equals to 0 power k and V is equals to 0 power j. Then W is equals to 0 power n minus k into 1 power n, because here equal number of zeros are followed by equal number of ones. That means Z is nothing but mod of UVW. That is, here we have considered UV as 0 power k. Complete length of Z is nothing but mod Z is equals to n. So if UV is 0 power k, then W will become 0 power n minus k. So it becomes 0 power n minus k, and also these zeros should be followed by same number of ones. So it becomes 1 power n. If you solve it, it is nothing but 0 power n and 1 power n. So we are considering uv as 0 power k, v as 0 power j and w as 0 power n minus k and 1 power n. Now what becomes mod z, which is equals to mod u, v and w. Here we got z as 0 power n and 1 power n. That means you will get n number of zeros and also n number of ones. Then our length of z will become 2n. So it becomes mod z is equals to 2n. Here, now we need to solve for u, v power I and w, where let us consider u, v power I and w is equals to, we know that u is nothing but uv of v to the power of I minus 1 and w. We can write it as v power I, we can write it as v into v power I is equals to v into v power I minus 1. So here we are just decomposing it into v power I minus 1. Now let us substitute the values which we have considered here, where uv is equals to 0 to the power k and v is nothing but 0 power j whole to the power of I minus 1, because we have considered v power I minus 1, and here w is 0 power n minus k into 1 power n. Now if you solve it, it is 0 power k, 0 power ij minus j, 0 power n minus k into 1 power n. This minus k and plus k gets cancelled. So then we will be left with 0 power of j of I minus 1 plus n and 1 power n. That means what? Here we are adding something to this n. That means the length of the mod z is greater than 2n. So therefore we can say that the given language is not regular. So the given language is not regular because the length of our z is 2n. But if you solve this, we have assumed that it belongs to L. But the length of this z which is greater than 2n, which does not belongs to L, that means it is contradicting our statement. So given language is not regular. Now let us solve one more question, which is the most important one. Show that L is equals to a to the power of p, where p is prime. So that means we need to show this language is not regular language. That means let us write all the strings which are generated from that language. L is equals to a to the power of p. Here p is prime. That means a square, a cube, a to the power of 5, a to the power of 7 and a to the power of 11 and so on. So we'll get all the powers as a prime numbers. So here we need to prove that it is not a regular language. So now let us take any one of the string as z. So now let us take z is equals to a to the power of 5. That means 5 a's. Now let us decompose this z into u, v and w. So here let me consider u as 2 a's, first 2 a's, v as a single a and w as last 2 a's. So you can decompose the first a as u, next 2 a's as v and last 2 a's as w also. Or you can consider u as single a, v as single a and w as triple a. So we can consider in any one of the ways. So now let us go with this, where u is equals to 2 a's, v is equals to single a and w is equals to double a. Now we need to solve for u, v power I and w, where let me consider I is equals to 2. You can take any value where I should be greater than or equals to 0. Here, if I is equals to 2, it becomes uv square w. Now, if we substitute all these values in uv square w, it becomes u is nothing but a, v is a square, because v square, we are just squaring this value, and then w is double a. It becomes double a and double a, which is nothing but a to the power of 6, but which is not, a power 6 is not in our language. That means it is not a string which belongs to L. We have assumed that uv power I w belongs to L, but it contradicts our statement, and this a power 6 does not belongs to L. So therefore, given language is not regular. So, in this way, we are going to solve the problems of pumping lemma, where we have to show that the given language is not regular using pumping lemma. So now let us see some of the properties of regular language, closure properties of regular language. That means if you consider there are two regular languages, L1 and L2. L1 and L2 are two regular languages where if L1 plus L2, if you are doing union of these two, then they are closed under union. You can say that L1 plus L2 is also a regular language. So that means if L1 is a language and L2 is a regular language, then L1 plus L2 also is a regular language, and you can say that they are closed under union. It is one of the property. The second one is concatenation. That means L1 into L2 is also closed under. That means L1 into L2 is also regular language. That means they are closed under concatenation. And the next one is clean closure. Clean closure is nothing but if L1 is a regular language, then L1 asterisk will also become a regular language. If L2 is a regular language, then L2 asterisk will also become a regular language. So that means they are closed under clean closure. Now, coming to the fourth one, they are also closed under complement, and they are closed under difference and intersection also. And here the seventh one is they are closed under homomorphism and also inverse homomorphism. So let us know what is homomorphism. See, L1 is a regular language, and homomorphism of two regular languages is also a regular language. That means you have a string. Here let us say h of 0 is equals to ABB and h of 1 is equals to AB. Here if you take h of 1001, that means now you are going to substitute 1 as AB and 0 as ABB. So this substitution till the end of the string is nothing but homomorphism. So let us see, h of 1 is nothing but AB, and in place of 0 we are going to substitute ABB, and there is one more 0 again, so we are going to substitute ABB, and for this one we are going to substitute AB. So in this way, substituting the numbers with the strings till the end of this string, that is 1001, which is nothing but homomorphism. So if the two languages are regular languages, then the homomorphism of those two languages will also be a regular language, and also inverse homomorphism of those two languages will also be a regular language. So, and also the last one is inverse of regular language is also a regular. So these 9 properties are nothing but the closure properties of regular language. Now let us see what are the decision properties of regular language. Here in the decision properties, if finite automaton cannot be constructed for a regular language, that means what, we are having a regular language so that you can write a regular expression for the regular language. So if you are unable to construct a finite automaton, that is NFA or DFA, so if you are unable to construct it, then it becomes undecidable. So here let us see one regular language. For this regular language we can write a regular expression, but we are not going to draw a finite automaton. That means we cannot construct finite automaton. If such case exists, then you can say that it is undecidable. And if you can construct, or if there exists a finite automaton, then it is called as decidable. So there are only two terms in the decision properties which are undecidable and decidable. If you cannot draw a finite automaton, it is undecidable, and if you draw a finite automaton, then it is a decidable. So these are some of the properties of regular languages, decision properties and the closure properties. So thank you for watching the video.